Hey, what's up, guys? So let's call this Woodbury as briefly Woodbury matrix identity, and hopefully, this will this I think this guy like Woodbury is some name of mathematician, and this will show in some statistics, and especially in the multivariate Gaussian condition probability. Also, yeah, so A would be the, let's say, notation. A will be n by matrices, and U will be I think, yeah. So C is k by k matrices. Then the U is like n by k matrices, and the V is like k by n matrices. Okay, so our goal is to prove this in this video. And before we do this, let's prove some simple version. So let's replace A to be identity and the CU to be identity. Okay, let's see whether we can prove something which is easier. Okay, so if you do this, then we will prove the simple version. So let's call UV inverse identity minus UI plus VU inverse V. Okay, so we need to first prove this. Okay, so these are some very simple proof that one can prove. Okay, but actually this is enough. Okay, so you can check if you, let's say, if I replace U to be A inverse X, and then replace V to be CY, then I think I would have chance to maybe there's no X here. Okay, so if I do this, let's say I will get I plus A inverse C. Sorry, forget about this. Okay, so let's just prove this simple one. Okay, and then once we prove this simple one, then we can like see how to derive the original one. Okay, so the proof idea just using the simple identity I equals to I plus P. So any P inverse is I plus P. Right, so basically this is I plus P inverse plus I plus P inverse P. Okay, so just expansion. So we know that I plus P inverse, right, will be I minus I plus P in I plus P inverse P. Okay, we have this. Okay, and obviously that this is symmetric, right? So you have I plus P inverse equals to I minus P I plus P inverse. Okay, you have this. And now okay, so now we are going to look at this, right? So what the standard proof is that obviously I just plug P equals to UV. Okay, so I got I plus U V inverse equals I minus UV I plus UV inverse. Okay, so the problem is that these two looks still different. Okay. Okay, so looks still different. So we need to have some way to like exchange this. Okay, but this is a simple exercise. That's very simple. You can check that I plus VU inverse V is the same as V I plus UV inverse. Okay, and the reason is that you can just cross multiply using just cross multiplication, right? So you can right. So if you times this to be the right hand side, so you times this to be right hand side, and then you times this to the left hand side, so you will get I plus to the right hand side. So you get I plus UV V is actually equals to I plus VU V. Okay, so stupid, right? These two are the same. Basically, you start from here and do the inverse, and then you can replace here to be here. Okay, finish the proof. Okay, and right, so this is the proof. Okay, but basically, I mean, you can, once you have this, then you can easily check that you can start from here and go to the general results. Okay, and yeah, let's do the full proof, the algebraic proof. Okay, hopefully this is very clear that you just do some simple calculation. And okay, so let's check. So let me just write u to be small u just for my convenience. So you can first check that u plus u cv a inverse u will be the same as u c inverse plus v a inverse u plus a plus u c v a inverse v. Sorry, a inverse u. Oh, so you can check this is true, right? It's true, right? Because it's true. And then you can, for this one that I can just output the A inverse U. So I got this. Okay. And the second one is that I got A plus U C V inverse U C equals to A inverse U C my inverse plus V A inverse U inverse. Okay. And for this one, the proof is the same as the what I did, right? Just very simple cross validation. So you're just times to write them just right down. So prove this. In order to prove this, you just need to do the basically you just swap all you can just using a previous proof, right? So I can just this UC can equals to like A plus UC V A inverse U C inverse plus V A inverse U my inverse, right? And this guy will UC will give you like identity plus U C V A inverse and the U C inverse plus V A inverse U inverse, and then you just times this, right? Go to the another side. So you get U C inverse plus V A inverse U should be equals to I plus U C V A inverse U. Okay, so simple calculation. This is U. The first thing is U, so it's U C V A inverse U. There's U C V A inverse U. Okay, so these two are the important identity. Okay. Okay, so now once we have these two, then we can like easily prove the general results. Okay, so let's dive into a proof. Okay, so let's write A inverse as a is A plus UCV inverse and A plus UCV A, right? So inverse, so this is trivial. Okay, so now I just expand it, so I get A plus UCV inverse and the identity plus UCVA inverse. Okay, so nice shot, right? We have like very similar. Now we do something weird, right? We get A plus UCV inverse, and that's right, A plus UCV inverse UCV A inverse. Let's see. So these two right, so we exchange, right? So let's see. Oh, this one looks a little bit non-trivial, but this one. Yeah, so you still the proof idea just cross, but just using the previous identity, right? So you can basically if you times this to the you can to the left hand side, you can see this. Oh no, sorry, I'm stupid. So basically this is just sorry, I'm stupid. So this is just expansion, right? You expand this. Okay, so it should be I should write as this. I'm stupid. Sorry about this. So let's see. Okay, so up to here is trivial. Now let's do this. Let's write this as A plus UCV inverse plus A plus UCV inverse UCV A inverse. Okay. So now we use this guy. Okay, so we get A plus UCV inverse plus A inverse U C inverse plus VA inverse U inverse VA inverse. right? So we fix this term, and this term we use this guy. Okay, so now your A inverse can be you just A inverse minus this will equals to this. So finally you can get A plus U C V inverse equals to A inverse minus A inverse U C inverse plus V A inverse U inverse V A inverse. Okay, so this is the proof. Yeah, I'll see you guys in the next videos.